Today I'm going to go over the assignment 2. And let's just basically do it together now, and then we'll discuss it as we go through the answers. And so this is going to, what you see here is pretty much what, this is the same format that you're going to get in the quiz on Wednesday. So this will be very similar. Won't be exactly the same thing, but it's covering the same ideas and requires the same type of skill that you've been developing by doing the lab and now the assignment. So here's the guidelines on this assignment. After coming up with the answers manually, you can write and run test code to check whether you have solved the problems correctly. So that's what I'll do today. You weren't required to do that for the assignment. It's just a suggestion that's what I think is a good idea. It's good practice for you. And we'll do that today. But you didn't need to submit that part. You just needed to submit your answers. So here is some code that's provided. Exercise 1 is to draw the UML class diagram for the bean jar class. So this is embedded as a multi-line comment. You can see that slash star text and star slash. That's the opening delimiter, closing delimiter of a multi-line comment. And then here's a second comment block. And inside this comment block is a description of how the bean jar class works. And so to answer the problem, to do the problem correctly, you need to read that and check your work against the requirements that are stated in this description. And then we have the declaration of the bean jar class. Here's a constructor. As you can see, there's a semicolon right there. This is a declaration of the constructor. It's missing the implementation. In fact, all of these just end with a semicolon. These function declarations are just declarations. There's no implementation. There's no logic. And then this semicolon right here terminates the declaration of the bean jar class. And then following that are the each function that belongs to the bean jar class with their implementation. So as you can see, here's the constructor for the bean jar class, and it has these two statements as its implementation. And then then here's an add beans function, and the implementation is omitted here, so you need to complete that. And likewise with some of the other functions. All right, the first problem is to draw the UML class diagram for the bean jar class. Let's go ahead and do that. So we can draw that class diagram just by looking at the class declaration. And I'm going to do that here, but I'm not sure if this is set up right. So let's go ahead and create the UML class diagram. And so in the UML class diagram, there are 3 areas. There's the class name in the top box, so that's going to be bean jar. And then in the second box is the member variables. Let's see, what's in there? I see there are 2 member variables, max number of beans and number of beans. It doesn't matter about what? You mean the order in which the member variables are listed? No, I want the member variables in the middle section. Is that right? That's what I showed. I think that's right. Yeah, try to put them in the middle section. Did I do that right? It's in the middle section, isn't it? Is that right? Mm-hmm. Okay. Yeah, if you switch those, then I mean, you know, maybe you'll lose a point. It's not a serious mistake. Yeah. Is that okay? Yeah. I did? Yeah. Oh, I didn't mean to say that then. Yeah. Oh, public and private?
Yeah. So
oh, no.
You want the positive,
yeah.
So you want the negative ones in the middle, and then the positive.
No, this is not the public. Oh, you mean in the code, not in the UML diagram? You mean in the code? Oh, the UML?
Yeah.
Oh, the center is. This is not for private and public. These are for variables, and this is for functions. So that it doesn't. The regions are not provided for public members and private members. That's not what these 2 regions are for. These are for the member variables and the member functions. And member variables can be public or private. You have to put the plus or minus sign in front of them. In general, the member variables will be private by common practice, but they don't have to be. The same with functions. The functions, typically you'll see a lot of public functions, but there can also be private functions. But we haven't actually done that in this class. All of our functions have been public, but all of our member variables have been private.
I think what she's trying to ask is, does it matter what the variables are supposed to be? I know it's supposed to be in the middle section, but the last section will be the functions?
Yeah, the last section has to be the functions.
So it matters where the variables.
Yeah, that's right. Right. But it only matters a little bit, okay? Just a little bit. All right, let's do the, that's so slow. I think when I do the video capture on my desktop, everything just slows up a lot here. And it queued up all these key presses. I have to be more careful. So the member variables typically are private. So I'll start with a minus sign there. So we have max number of beans, and that will be an int. Did I get that right? max number of beans, and then we have number of beans. Oops, be careful. So those are the member variables. The member variables go in the center, and they're typically private, although they don't have to be. And then the functions go in the lower region. And I'll start with the constructor. And the bean jar this bean jar constructor takes two arguments. Max number of beans and initial number of beans. Well, let's see what that looks like. So max number of beans, which is an int. And the initial number of beans, which is an int. And for UML, the data type follows the variable name. There we go. Just made it. Oh, not quite. And now we have, now we need to basically go through the other member functions. There's add beans, which takes one argument called number of beans to add, and it returns a bool. So add beans. It takes one argument called number of beans to add. It's an int. And the function itself returns a bool. All right. I mean, normally with UML, you would use a drawing system. And there are tools specifically designed to create UML diagrams. And but I wanted the UML diagram, rather than requiring everybody to learn a tool and submit UML diagrams that were generated from the tool, I just had you embed the UML diagram inside the source code. It's just easier to keep things. It takes a little longer to draw it up. Okay, so that's add beans, and then the next one would be remove beans. And remove beans returns a bool. So it returns true if the removal of beans completed as expected, as requested. But it returns false if something went wrong. In other words, if I had one bean in the jar and you told me to remove 2 beans, I'm going to return false to let you know that what you asked me to do is inconsistent with the state of the bean jar. These are all public in this problem. And then we have another function, get number of beans. This just returns the number of beans that are currently in the jar. That returns an int. It takes no argument. Is that it? That's it. So there's the Uml class diagram. And that'll be the answer size 1. Let's look at number 2. Implement the add beans function. Let's start with the naive implementation. And that we have a current number of beans, and we're simply going to add to it the number of beans to add. You can see there's a member variable called number of beans. That represents how many beans are in the jar. There's another member variable, max number of beans. That represents how big the jar is. What's the maximum number of beans that I can put in there? So number of beans is constrained by that max. So number of beans should never exceed max number of beans. And it could also never go below 0 as well. And so if we want to add this amount of beans, number of beans to add, then the naive way to do it, or the simple way to do it, is just to add the number in there. But the problem is that may exceed the capacity of the bean jar. So, in fact, we can check on that. So if number of beans is greater than the max number of beans, then we have a problem. So what we could do there is just set our number of beans to max number of beans. Oh, but wait a minute. So it's kind of like an error condition. So what do we do in this error condition? Do we do anything? Maybe we should just reject the request. Huh? We can either reject the request, or else we can, fill up the jar as much as we can. But in either case, we'll return false to let the calling code know that there's an issue. So to find out what we need to do, we have to go back and read the problem statement. Wait a minute, let me do what I just said first. So we'll return false in this case. And else we'll return true. So true means everything was okay. Also notice one thing I'm not checking here. I'm not checking that number of beans to add is negative. Because if number of beans to add were to be, say, negative 100, and number of beans in the jar were to be 10, then we would have a resulting negative number of beans in the jar. So I'm not checking that, but we could put that in there. Maybe that's a good idea to put in there. So look here at the comment that describes how the the bean jar functions. The functions to add and remove beans, return a Boolean value that indicates whether the operation succeeded or failed. When one of these functions fails, then the number of beans in the jar will not have been changed. Oh. In other words, actually this should be for example. That's actually what I should have said. For example, if a bean jar has a capacity of 10 and there are 9 beans currently in the jar, then calling add beans 2 will return false and the number of beans in the jar will remain at 9. So that's the specification. That's how the program is supposed to work. So we're not doing that. We're providing an alternative implementation. So we're not satisfying the specification. So I'm going to want to redo this. And I can see how I would like to do it. If the number of beans plus the number of beans to add, if I take the current number of beans and I add the requested number of beans to add, if that exceeds the max number of beans, then I will return false. To say that the state of the bean jar is not changing, I'm returning false to say that there was an error, user error. And if this condition is not false, it's not true, that means we're not exceeding the capacity of the jar. We'll modify the number of beans in the jar here, and then return true. Okay, now we have an implementation that satisfies the requirements. What's that? Oh yeah, we need a semicolon. Thanks. All right, let's look at number 3. And number 3 is to do what? Add code to the to test the remove beans function. Let's see if is that right? Add code to test the remove beans function. Make sure that the test code executes all lines of code in the remove beans function. So we already have test code in here. So this test code, let's look at what we have, the existing code. We create an instance of the bean jar class here by calling the constructor. We have a jar that has a capacity of 10 beans. It has an initial number of beans equal to 5. After we do that, we're testing that the get number of beans function correctly returns 5. So we call get number of beans on our bean jar object and compare that to 5. And if this expression is true, then get number of beans is functioning correctly. Our code is functioning correctly. The code that deals with this part of the implementation. And then, so that expression is passed to assert. So if that expression is true, assert just silently returns without doing anything. If that expression is false, then the assertion will terminate the program and print a message. And then we're implementing add beans here. we're testing add beans. We're adding 3, so that should give us 8 beans in a jar. And so the next line we test that get number of beans, in fact, returns 8. And then we try to add 4 more beans to a jar that has 8. That would give us 12 beans. That exceeds the max. So this expression here, this add beans, and we call add beans, that should return false, because we're trying to add too many beans. So it should return false. So we assert the opposite. So that negation right here converts the false into true, and that true value is then passed to assert. So that assert just quietly returns, doesn't do anything. If this is confusing for you, you can think of it like this. That's an equivalent expression. Not a value gives you the same result as the value equal false. By the way, value equal false, that's not assignment, that's comparison. So if the value equals false, then that expression, that the value equals false, that expression is true. And you see this actually, see this in code, but you tend to see this, you tend to see programmers writing this instead. And it's shorter, first of all. And it's just kind of like a style of thinking. The more you work with this stuff, you sort of settle into this style. It just somehow feels more sort of expressive or logical. But when you get started, it's maybe a little bit confusing. All right, so then we want to make sure that after add beans returns false, we want to make sure that add beans didn't incorrectly, modify the number of beans in the jar. So we want to test again that there's still only 8 beans in the jar. Now we need to add code to test that remove beans works correctly. And you've got, in a sense, you really have a template here on how to do that. Let's go ahead and do this. So we have a choice. We can either create a new instance of the bean jar class, call it bean jar 2, or we can just continue with what we have. We have a bean jar with capacity 10 and 8 beans in the jar. So let's just continue. So let's just assume that we won't need to create another bean jar instance here. So let's go ahead and try to remove some beans. We have a bean jar, and we're going to remove beans. And we'll try to remove, we have 8 beans in there. Let's remove 1. And so when we remove 1 bean, it should be no problem. But we'll need to check that, that the bean jar has 7 beans in it now. That's what the test code looks like. Get number of beans. Just checking that. Get number of beans. Good. And let's do this again. We have 7 beans in the jar. Let's try to remove 11 beans. Oh, but that should fail. So when we call remove beans with 11, that should return a false. So let's negate that false to make it true, pass that value to assert. Actually, you know, the more I think about it, it doesn't really, this is a lot sort of easier to see. And I think this actually is the correct style, to tell you the truth, because remove beans, the function itself, it doesn't sound like it's a Boolean method. It doesn't sound like it evaluates a true or false. This true or false is just an error condition that's being returned. But I think this is actually the better style to use, to tell you the truth, now that I think about it. You can use whichever one makes sense to you. They're both acceptable. Yeah. That's right. But they're equivalent. So you can pick the one that makes sense to you. I think this is the best one to use here. You know, a lot of this has to do with, you know, like your judgment. You know, when you're writing, say you're writing a paper, or you're writing an email, you know, should I say, come on guys, let's go? Or should I say, you know, would you like to go now? Should I be more polite and formal, or should I be, you know, it depends on your situation. So a lot of, when you do coding, it's like writing. And it's like you're writing for, you know, you're writing for the computer, obviously. The computer doesn't care about style. It's the humans that care about style. And so you're always making decisions about how can I name the variables, the functions, how can I express the comments in a way and arrange the logic that makes the program easy to read and understand. And there's no, you know, definite answer about right and wrong there. I mean, there's guidelines and you can think about it and get better at it as you go along. But there's no real right or wrong. It's hard to be right or wrong. It's more of a kind of a gray area. Okay. So now this here, this test here makes execution enter into this branch. And this test up here makes the execution pass through this branch. And so we're, at this point in time with these two tests, we've covered all of the code. But one of these tests by itself, like say just this one tests that branch that returns true, but it doesn't return the branch that returns false. So just using this as your test would be an incomplete test. It has poor coverage. That's the word that's used, coverage. So test code should have good coverage. Good coverage means, among other things, it means that all lines of code have been tested. It also means that all special cases, extreme cases, have also been tested. What happens when we pass in a 0? What happens when we pass in a negative value? What happens when we pass in the capacity? Max means is 10. What happens if I pass in a 10? So you want to test what are called the, what do they call it? The border cases. I forget the term actually. Like the edge cases. You want to test the edge cases, like a 0 or a 1 or something like that. But this would be good enough for me on if you were to answer like this. This code here tests all lines of code in the function. All right, number 4, provide an alternative implementation of the add beans function that sets the number of beans in the jar to its maximum when the added beans exceed the available capacity. Oh, you know what? I was talking about this. This is remove beans. It doesn't test this add beans function. This is testing the add beans that's provided in the code here. So, but the comment is the same, that here is here is remove beans, which is hard to see. This is remove beans, and there's 2 branches in here. And the test code returns false in one case, and returns true in the other case, so that all lines of code of the remove beans function has been tested. All right, now let's provide an alternative implementation of add beans that sets the number of beans in the jar to its maximum when the added beans exceeds the available capacity. Okay. The function should continue to return false. Well, I'm just going to make this easy. I'm going to copy this. So we're going to continue. Here we have the bad situation where we're trying to add too many beans, so we're going to return false. But what we're going to do is we're going to fit in as many beans as we can. So the number of beans is set to the max number of beans, and all the excess beans are just discarded. They're just lost. That's it. That's 4. I'm just going to let the jar fill up. You're asking me to add too many beans. Well, I'll fill the jar up all the way. I'll set number of beans to the max. Then I'll return false to let you know that was the problem. So that's an alternative implementation. It doesn't satisfy the original specification, but it satisfies the new specification. Let's look at 5. Provide an alternative implementation of remove beans that sets the number of beans in the jar to 0 when the beans to remove are greater than the number of beans in the jar. The function should continue to return false in this case. Let's go ahead and grab that function. Here it is. So here's the case. It's the case of returning false. The other case is we're not going to modify that. This is the normal situation when the removal is obvious. But here, we're being asked to remove more beans than we have. So we'll remove as many as we can, but we're not going to remove. We're not going to go to a negative value. We're just going to have 0 beans. That's it right there. That one is 5. That's it. Okay. All right. Let's test our answers. I'll grab this whole section here. Say it again. What? Yeah, the second quiz will look very much like this. It's not going to be the same thing. You'll have to do something a little differently. Look at the lab. What was it, lab 5 or 4? I don't remember which one. Huh? The school bus example, take a look at that. That wasn't part of the lab, but I presented that in lecture. I think you should look at the school bus example as well. So I'm going to ask some kind of a question. Either I'll give you a UML diagram and ask you to implement it, or I'll give you the declaration of the class and ask you to draw the UML diagram. I will be asking you to implement some of the functions. I may or may not provide code in advance. So I may not provide any sample code. I may just ask you to provide the implementations to the functions. Okay? But the level of complexity will be about this level here that you see here. Okay? So here it is. I'm not going to put the Uml class diagram in there, but for a lab exercise you would do that. And here's the functions. This is add beans. Let's grab that. Now we have two different versions here, so let's do the main version, or the initial version. And we have remove beans, so get number of beans, and then we have test case here. Let's get that in there. Notice, actually, I'm putting everything in a single file because it's a pretty small program. But in the other examples that I demonstrated, I used separate files for the header file, the .h file, for the implementation file, the .cpp file. That's a more standard sort of approach. But you do see this as well, especially for small classes. We have the class declaration, and then we have the implementations following that, right inside the main program. So there is that. Let's see if that runs. Max number of beans. All right, so we've got a problem there. And that's in line 38. There we go, that works. You know, for your answer on the quiz, that would be full credit. I mean, if you misspelled it like that, it's just a silly typo. But when you want to run the program, of course, you need to fix those typos. All right, that's it for the assignment 2. Any questions? Any additional questions? Well, there is something else that I should explain, actually, and this is a topic that that I am required to cover, and it's also very important. But I haven't included this topic in the quiz. But I may include it in the final. And that has to do with const or constant. Declaring something constant. If I didn't want max number of beans to ever change, then I would declare it like this. Actually, you wouldn't do that here, but it doesn't have to do with public or private. Yeah, I'm going to do the member functions here. This is, if I put const after the function like that, I'm telling the compiler something. I'm telling the compiler that when this function runs, it's not going to change the state of the object. The function is constant in that sense. The function may change the state of something else, but it's not going to change the state of the bean jar instance that it runs against. And this is, you'll see this is very common, of course, and it's very important to use. Huh?
It's called the accessor.
This is an accessor method, that's correct. Accessor methods in C++ usually start with the word get. And what's the opposite of it? Accessor and, what's the put method for, what's the opposite of accessor? Are they all accessor methods? So set number of beans and get number of beans are all called accessor methods? I think so. Accessors, yeah. So you usually have get and set. So another possible function declaration would look like this. This is very common. You have a get method and a set method. Now the set method would take something like this. So this is, it's like it provides an interface to that private member variable number of beans.
Like mutator or whatever it's called.
Oh, mutator, that's the word. Thank you. That's the one I couldn't remember. So you've got accessors and mutators. This is an accessor. An accessor, it just gives you a way to access, to read the value of a hidden member variable. And this is a mutator. It's a way to reach in and modify the state of a hidden member variable. So these are what, and this is very common. And this also depends a lot on the language that you're in as well. You'll see this, of course, it's very common in Java. And Java language follows this convention strictly. And then, or programmers follow it rather strictly. And then languages like C#, you'll see a slightly different syntax where you have something called properties and so on. But I'm not going to get into that. But in C++, this would be the typical. Oh, and this is a mistake. Look at this. Const here is won't work because if we're passing in a number of beans to set, then we're modifying the state of the object, so we can't declare that function as const. When we call the function, the job of the function is to modify the state of the object. It's to set a new value to number of beans. So we cannot declare that as const. If we do declare it as const, we'll get what? We'll either get a runtime error or a compile time error. What do you think it is? Anybody following this? It's hard to lecture about. Yeah, it's the kind of thing where it's better if you just do it, and think it out yourself. But you do get a build time error. All right, so this is, I'm going to take that one out. But this would be the normal. Now see, remove beans and add beans. These modify the state of the object. Those are not going to be const. Get number of beans will be const. What happens if I try to compile this? It will fail. Because the prototype for get number of beans does not match any in-class bean jar. And it's smart enough to know that there's a candidate for it. It says this is probably what you want to match, but what you have declared here, your implementation of get number of beans does not match any function that's declared for the class. Because we declared get number of beans as being const, it's considered by the compiler a separate function. It's not the same function that we provided an implementation for. So we need to continue. We need to declare this function here where we provide the implementation. We have to have exactly the same function signature, or the compiler was calling it a prototype. We have to have exactly the same prototype. And this will accept it now. There we go. All right, let's take a look here. So that's quiz 2 that's coming up. I think we're ready for that. This is not going to be a tough quiz. It's not like you have to solve an algorithm problem. You have to do, addition and subtraction. You got to figure out how to use, Boolean expressions in if-else clauses, and that's it. And then how a class is organized. So it's pretty straightforward, and I think we've covered the material, a lot. I mean, 3 lectures on this. I think all of you can get 100% on this test. All of you. Well, you got to practice a little bit, right? What's the question here?
So quiz 2 isn't going to have anything from quiz 1 in it. It's just going to be like classes.
Pretty much what you see here, yeah. Right. It's going to look just like the assignment. There'll be some test code in there.
They're not gonna give us any, like, free code.
I may not, I think, because I wrote the quiz already, and I don't remember if I put some code in there or not. So I may,
I think you should.
it's too late, I already sent it to duplicating. All right, I think that's enough for today. I don't want to overload you anymore. Question?
Yeah, that was a good question.
Maybe 8. I think I had 8 questions. 8 little questions.